I've been reminiscing. It's a little bit like looking back at photos of your children, looking back at the good old days. So the days when we first learnt about inverses. So, for example, do you remember when we learnt that the opposite of adding was subtracting? Happy days, eh? Yeah. So, to solve that equation, we just took away 2 from both sides. And remember that exciting lesson when I talked to you about killing fractions. So we learned that the opposite of dividing by 3 was multiplying by 3. And then, when we got a bit older, we learned that the opposite of squaring was square rooting. So we could undo squaring by square rooting, and that was all very exciting. And then a bit more recently, we've learnt about inverses like this. So if you've got something to the power of x, you undo that by doing log to that base. So e to the power of x, you do log to the base e, which we call ln, and you do that to both sides, and it gives you an answer to the equation. And this week we've met the same thing with our, sorry, it's lower down here, with our inverse trig functions. So we talked yesterday about if you want to undo arc sine, which is sine to the -1, you just sine both sides. And if you want to undo arc cos, you just cos both sides. And if you want to undo arc tan, you just tan both sides. And this is just algebra. This is, this is so far removed from right-angled triangles that it doesn't matter. It's just we're now solving equations. We're solving equations. Now, actually, we have already used this concept of inverse because, for a long time now, we've been solving equations like this. We've said, right, sine x equals 0.5. So to work out the answer, we've been doing sine to the -1, shift sine of 0.5. We're now calling that arc sine, but it's the same thing. So for a long time now, we've been doing the opposite of this, haven't we? We've been undoing sine by doing shift sine of both sides. And in an expression like this, this is the angle, and this is the sine of the angle. And now, I can bring it back to right-angled triangles, because what's the sine of the angle? Well, in a right-angled triangle with an angle that size, it's the opposite side divided by the hypotenuse side. So in these sorts of statements here, of course it's not going to let me. Hang on. Oh. Right, in these sorts of statements, this is the angle. We're saying, okay, this is the sine of the angle, so we're doing shift sine of that gives us the angle. So, sorry, x is the sine of the angle. So I think the first thing it's worth making a note of is in this statement, this is the angle, this is the sine of the angle, and we work out the angle by doing shift sine of 0.5. Here, this is the angle, and what we're doing is we're working out what the sine of the angle is by using sine. So we've got two things which are very opposite, but I think it's important to understand that in a statement like that, this is the angle, and it's confusing because we're working in radians all the time here. So these aren't numbers that we're used to in degrees. With degrees it's 60 degrees or 90 degrees or 370 degrees. When you're dealing in radians, it's either a horrible number like 1.748 or it's in terms of pi, which isn't good. So that's the first point I wanted to make, that what we're doing here, signing both sides of an equation, is the complete opposite of what we have been doing to solve that sort of equation. And this was the key technique from yesterday. If alpha is acute, so this is the angle, and we're told that the arc cos of some number x gives us that angle, can we find an expression for sine alpha and tan alpha? So see if you can go through the process that we went through yesterday. This is a complete repeat of what we did yesterday. I think it's just worth reminding ourselves. I've done it again. Should have two C's. So cos both sides, that gives you what cos alpha is, and then you can use the identities to work out what sine alpha is, and once you know what cos alpha and sine alpha are, you can write down what tan alpha is. Cos both sides. If I know what cos alpha is and I want to work out what sine alpha is, I use the fact that sine squared is 1 minus cos squared. Cos alpha is x, so cos squared alpha will be x squared. And that means that sine alpha is plus or minus the square root of 1 minus x squared, except alpha is acute. Between 0 and 90, I know that all three, sine, cos and tan, are all positive. So actually, I don't need to worry about the negative, it's just positive. Cos alpha is x, sine alpha is plus the square root of 1 minus x squared, so tan alpha will just be that over that. Tan is sine over cos. I know we did it the other day the other way around, but that's just because we started with the example yesterday with arc sine, not arc cos. So tan alpha is sine alpha over cos. And this idea of undoing arc cos and undoing arc sine and undoing arc tan is the second key thing, I think, with this. The first key thing is sketching the graphs. And to do that, you need to remember how we limit the domain of sine, cos and tan and draw the little sort of circular picture of sine and arc sine, domain, range, and then this. So let's just finish by solving a couple of questions like this. So let's just do these ones and this one. So this is, again, so far removed from right angled triangles, this is just algebra. So if it said x squared equals something, I'd square root. It doesn't. It says arc sine of x equals something. And remember, that's the angle, that's what the sine of the angle, that's the angle, that's what the sine of the angle is. So I'm just going to sine both sides and whack it into my calculator and get my answer. You should get exact answers for number 7, and 8a is one you need to round. Are we all calculated up?
My pin back stab myself with a pin.
So for b, you just get x is equal to cos of 0, and the cos of 0 is 1, so that x is 1. For d, I've cosed both sides, so 2x is the cos of pi over 6, which is a half, is it? Yeah, shift 6. Radians. Remember, we must be in radians for this. Sorry, root 3 over 2, and then that's what 2x is, so x is just half of that, so you divide that by 2, you get root 3 over 4. And with e, before doing anything, I need to get the, in this case, arctan on its own, just like when we were using e of x or ln of x, we got that on its own, so I add that to both sides. I then tan both sides. And the tan of pi over 4, that's 1. And then for a equation 8, I just cos both sides, so x is equal to the cos of 2, and the cos of 2, remember 2 is the angle, but we're in radians, so that's why minus 0.416. Right. That is trig done, okay? That is, well, except it isn't, because we have to differentiate trig, and so that crops up a bit later when we do differentiation, but it's nice. That's nowhere near as hard as this. So let me just go back to OneNote. So what I have done is I've put the revision sections here. You've got 3 Maths Genie sections, so that's the sec, cosec and cot, all the double angle stuff, including, and the stuff we did on composite functions, so 3 sine theta plus 4 cos theta. Maths Genie doesn't do arc cos, arc sine, arc tan. There will be one inverse trig function question on the little assessment we do. So we're going to do that little assessment second week after Christmas. We'll agree when we come back what a good day would be, because hopefully lots of you will have received offers and interviews and things like that, so it might be that you're not available on every day, so we'll try and pick a day that suits everyone. I mean, it'll be a short one, 45 minutes, so we can do it within the hour, even with extra time. And yeah, so I want to encourage you to commit some time to prepare for that. I hope you've been sort of working through it anyway. And there's sort of a hierarchy of revision, really, if you think about the difficulty. So Maths Genie, I mean, nothing at A level is easy. Nothing at A level is easy. Well, okay, some subjects that I won't name, but in maths, nothing at A level is easy. But Maths Genie is as easy as it gets in terms of practice. So that's a really good place to start. I then think the Now Try This questions in the red revision guide, they're probably a little bit harder, but they're quite nice because they tend to relate directly to what's on the page above, so they're a good place to try as well. These two, I'm not really sure which way around to put them, because the mixed exercise, as the name suggests, is mixed, some easy, some hard. But in the textbooks, at the end of each chapter, you get a mixed exercise. Just beware, if you are aspiring to an A star, then yeah, all of those questions are worth a go. But some of those questions are just insane. So just try and temper your enthusiasm for that. CGP workbook is generally harder than that, although it doesn't have the insanely hard questions that the mixed exercise does. And then the gold standard, which we're not ready for yet, but which we will be ready for not long after Christmas, is we start getting into past papers. I feel a little bit more optimistic now that we're going to finish the content by Easter. And that means that we have all that time after Easter to commit completely to past paper practice, but I'm going to get you into past papers before that, because I want you to start getting used to the way the papers look and the way the questions look. And I've already got a pack of papers ready for you when that time comes. For now, this is where we're going to get to. So it's up to you, really, isn't it? It's up to you how far you go. But this trig work, it's hard, isn't it? So it is worth committing some time to revising it. Right, so for the rest of this lesson, we're going to have greatest hits of trig, okay? Do they still do now? That's what I call music albums?
I don't know.
No? So when I was young, I was probably sort of 40, I got now 7. And I'm sure they got up to like, it was, you know, well over 100, was it? Anyway, so there you go. Those were the days, happy days, back in the 80s. You don't know. You're so unfortunate all being born in the 80s. So, in the textbooks, I picked out 3 questions which I think are good to have a go at, just to sort of remind ourselves. I'm hoping you'll have your I Love Trig sheet handy. And they're all on page 227 or maybe 228.